Hi Stats class! My name is Angelina and today I will be presenting my project comparing median home prices and the price of unleaded gas per gallon since 1994. This first sheet shows the raw data and my random sample. The original population size was 330, and from there I used the rand function to select a random sample of 30. Next, I did a summary sheet on the median home prices dataset. To construct a frequency distribution, I used 7 classes and derived a class width of 34,060.97. I plotted a histogram of the results on the right, and you can see that this shape here is a bit deceptively bell-shaped, but I would actually argue that it's more left-skewed with a few outliers at that 344,000 mark. And the second table here shows the associated frequency distribution. And then scrolling down a bit, the third table shows my measures of center, measures of spread, 5-number summary, and outliers. I identified 3 outliers in this dataset, all above the upper fence, and I concluded that the median is likely the most relevant measure of center for this data set, considering the presence of outliers. However, you can see that the coefficient of variation here is relatively low, and that's because it's below 100. So the rest of the data points are pretty clustered around the mean. And speaking of the mean, I highlighted row 15 because it has the lowest z-score, which means that this is the value that is closest to the mean. And that is a z-score of 0.086. I also highlighted 2 rows at the bottom, which are significantly high, or 2 standard deviations above the mean. And this represented 6.66% of the data set, which agrees with Chebyshev's rule that at most 25% of the data will fall above or below the mean by 2 standard deviations. And then while this data set does not have a mode, this is a single-moded data set distribution, meaning that there is one peak, which you can see here. On this next sheet, still using the median home prices dataset, I did a confidence interval about a proportion, and I wanted to estimate the percentage of months since January 1994 when the median home price had been above 250,000. So I started by getting my count to determine the proportion in the sample above 250,000, and I calculated a test statistic of 1.95996. After finding the upper and lower bounds, I concluded that I am 95% confident that the actual percentage of all months since January 1994, when the median home price was above $250,000, was between 3.3% and 30%. And then moving on to my hypothesis test, I wanted to test the claim that a majority, or over 50% of the months since January 1994, had a median home price below $200,000. And once again, I started by getting my count for my proportion, and I constructed my null and alternate hypothesis with a significance level of alpha equals 0.05. This is a right-tailed test, so I selected higher, and I got a test statistic of negative 1.09545 and a p-value of 0.86334, which I used to formulate my conclusion. I concluded that at the alpha equals 0.05 level of significance, there is not sufficient evidence to support the claim that the majority of the months since January 1994 had a median home price below $200,000. This is rejecting the failing to reject the null hypothesis, and you can tell because that p-value is quite significantly higher than the significance level. Finally, I wanted to perform correlation analysis between the median home price data set and the price per gallon of gas data set. So to do so, I constructed a scatter plot with median home price on the x-axis and price for 1 gallon of unleaded gas on the y-axis. And I displayed a trend line here to get my regression equation. And I did the correlation to get an R value of 0.69027, which leads me to believe that there is a strong linear correlation between median home price and cost of gas since January 1994. I used the regression equation to do these next steps. The first was to estimate the median home price if the cost of a gallon of gasoline is $3 per gallon. And I got $265,272.89. And then I did the same process, substituting the median home price of $475,000 to get a value of $4.82. So between these two estimations, I would probably trust the estimate of $3 per gallon better. Because I do not have any median home prices in my data set as high as $475,000. In fact, it caps off at $344,000. So there's nothing really in my data set here to support those higher values. And who knows if this linear relationship would continue higher up in those prices. So yeah, this is my project. I had a great time coming up with these conclusions, and I look forward to hearing about your projects. Bye, class!